All right, let's talk about one of the most common things that trips people up when they're working with transformer models. If you've ever tried to feed your own text into one of these powerful models, you've probably run headfirst into a wall of confusing errors. It seems like it should be simple, right? But getting your data into the perfect shape is often the biggest hurdle. So let's walk through this together, and by the end, we'll have a simple 4-step checklist to get it right every single time.
We're going to frame this whole thing as a troubleshooting journey, one you've probably been on before. First, we'll tackle that initial batching requirement that gets everyone. Then, we'll solve the padding puzzle, what to do when your sentences are different lengths. After that, we'll pull back the curtain on the attention mask secret, which is crucial. And finally, we'll quickly cover what to do with those extra long sequences.
Okay, Section 1, the batching requirement. This is where that first frustrating error usually pops up. You've got a sentence, you've tokenized it into numbers, and you're all set to see some magic happen.
So you take your tokenized sentence, your tensor of input IDs, you pass it to the model, you hit run, expecting amazing results, and bam! A big, ugly red error message just staring back at you. It's that classic moment of, wait, what did I do wrong?
I mean, you followed all the steps, you converted your text to numbers, so what gives? What's the problem here?
And here's the answer. And honestly, it's surprisingly simple. These models are built to be workhorses. They're designed to process batches of sentences all at once for maximum efficiency, not just one at a time. Visually, this is what you sent the model, just a single, flat list of numbers. The model sees this and thinks, nope, this isn't the right shape. I'm expecting a batch. And the fix? Oh, it's so simple it's almost funny. You take that exact same list of numbers, and you just wrap it in another set of brackets. That's it. You've created a list of lists, which is a batch that just happens to contain only one sentence. Now the model is happy.
So this is the first crucial concept, batching. It's just the idea of grouping your inputs. And the key takeaway is that even if you only have one sentence, you still need to put it into a batch of one.
All right, so we've solved problem number 1. But, as you know, that often just creates a new one. The second you try to batch sentences that aren't the same length, a new problem pops up. Welcome to the padding puzzle.
Let's say you have 2 sentences of different lengths. When you try to stack them together, you hit a wall. That's because all the data needs to fit into a single, nice, neat rectangular block called a tensor. And you just can't make a perfect rectangle if your rows have different lengths. It just doesn't work.
The solution to this is something called padding. The idea is super straightforward. We just add a special, meaningless padding token to the shorter sentences until every sentence in our batch is the exact same length. Problem solved, right? Well, not quite.
And this is where things get really weird and kind of frustrating if you don't know what's going on. Take a look at the model's output, the logits, for our second sentence. When we process it all by itself, we get one result. But when we process it inside that padded batch, the results are totally different. So padding fixed our shape error, but it completely broke our model's predictions. Why?
This brings us to the most important piece of our whole journey, the attention mask secret. This is the final ingredient we need to tell the model exactly what it should pay attention to, and more importantly, what it should ignore.
So here's the real issue. The magic behind transformers is their attention mechanism. It looks at every single token in the input to understand the full context. But that means it's also paying attention to all those fake padding tokens we just added, and that pollutes the meaning of the real sentence and gives us the wrong results.
We solve this with an attention mask. It's just another tensor, the exact same size as our input, but it's incredibly simple. It's just a bunch of ones and zeros. A 1 tells the model, hey, pay attention to this token, it's real. And a 0 tells the model, nope, this is just filler, ignore it completely.
And this right here, this is the big aha moment. Just look at this table. Every real token in our sentence gets a 1 in the attention mask column. But as soon as we hit those padding tokens at the end, boom, the mask switches to 0. We are literally giving the model a map that tells it exactly where to look. And just like that, with that simple addition, we have success. When you pass both the padded inputs and this new attention mask to the model, the outputs are now correct. The results for the batch sentences are now identical to what they were when processed alone. We fix the shape, and we fix the logic.
We're almost there, I promise. There's just one last, very practical problem we need to solve. What happens when your text isn't too short, but is actually longer than what the model can handle?
See, most transformer models have a hard limit on how many tokens they can process at once. A really common limit you'll see is 512 tokens. If you try to feed it a sequence that's 513 tokens long, it's just going to crash.
So you've really got two main options here. First, you could find a special model, like a longformer, that's been specifically designed to handle thousands of tokens. Or the much more common approach is to simply truncate your sequences, which is just a fancy way of saying you chop them off at the model's maximum length.
Okay, let's put it all together. This entire troubleshooting journey really just boils down to a simple 4-step checklist. Step 1, always put your inputs into a batch. Step 2, pad that batch so all your sequences are the same length. Step 3, create that all-important attention mask to tell the model what to ignore. And step 4, make sure you truncate any sequences that are just too long.
If you follow these 4 steps, you will conquer the most common data prep errors, guaranteed. Your data is now perfectly formatted and ready to go. The only question left is, what amazing problem are you going to solve with it first?